All right, this is Ken Rosever. We're talking about standard normal, what is it called? Standard normal values advanced. And I wish that the example here were an easier one to explain. This is like my fifth draft, but it's not. I can't help that. So what I propose is I'm going to do it first in here. I already did a second ago. And then I'm going to show you why I type it in the way I do. In order to answer this question, which is finding C, so that between C and 1.12, between those two Z values, we have 84.59% of the population. They want us to find a C that makes that happen. I'm going to have to use this button here. I'm going to use a parenthesis. I'm going to do P of Z less than 1.1, whoops, 1.12. And then I'm going to get out of that, and I'm going to minus from that 0.8459, and then I'm going to close that parenthesis and hit enter. And it comes out 2.00019. So it comes out 2 pretty much, but I'm going to call it -2, and you'll see why in a moment. Okay, so and it says very good. Okay, so let me explain now how I process through that in the calculations. When they ask me for a C and they give me a 1.12, they're telling me here's 1.12 and there's some other value out there which we now know is at 2, but its location is such that, you know, it could be anywhere, but its location is specifically where, whoops, this is positive. I hate when I do that, sorry. So positive 1.12 be about right there. And this thing's location is such that 84.59%. Why is my pen not working? Hold on. 0.59% is between there and there. Well, that's great, but it doesn't tell me what C is. I know this is 1.12, but I need to do something else. So the trick is, I know that if I looked up, just forget this 0.8459 for a second is there, and this C. I know that if I looked up 1.12, this whole thing would be P of Z less than 1.12. And so if I found that, then I would have this whole thing. And so let's do that. And you saw where I typed that. That was part of the argument I had in my calculator. I had this, and then I had minus 0.8459, and then I got an answer, and I put down the opposite of it. Okay, so I'm going to look that up real quick. Tables. 1.12. So 1.12 is 0.8686. So going back to here, I now know that 0.8686 is between here and the end. Here and there. Okay? But they're telling me between this and C is 84.59. So let me do a little erasing here and show you how this makes sense. Okay, so I now know this is 0.8686. Well, here's C. This is 0.8459. Now, isn't it true that whatever this is over here, that this, let's call it A plus B, which is 0.8459, has to add up to this. So 0.8686 equals A plus B. 0.8686 equals A plus B. But B is 0.8459. So A, this region over here, is 0.8686 minus 0.8459, which is 0.0127 and that is why I subtracted. See, I subtracted here. That's why I subtract over here. This minus that gives me 0.0127. And that is the area of this little piece over here that is to the left of C. And we know that if we have what is to the left of C, then we can put that in to our ALEKS calculator and figure out what C is. Now, how do we do that? Well, we have to do it carefully, because what the ALEKS calculator is set up to look up is percentages to the right of a given value. There is a button on the calculator that says Z of little box and equals. And if you put in Z of 0.0127, it will return to you a value over here because it looks up what Z value will cut off this percentage to its right. Okay? What Z value has that amount to its right? That amount right there. So if I put in Z of 0.05, it would find for me the Z value that leaves 5% on top and 95% on the bottom. So it always returns to me the right answer. But where is my piece over here? It's on the left. So because of symmetry, we know that if we plug in 0.0127 and we get 2.0000, because of symmetry, that our answer is actually negative 2.000. And that's why I took the opposite of the answer I got. Let me pause. I'm not going to have time to do another one on this video, so I'll do it on the next one. Hopefully that makes sense to you. If it doesn't, watch the other one, then come back and watch this one again. All right.